13-8, and here we go. It gives you a lot of the information. I tried to recreate the little ANOVA table over here. Hopefully I put everything in right. I kind of did it hurriedly, but it says for A, it says write the regression equation. So when you have this, it's simply a matter then of writing. I mean, they give you the material, and so it's y hat is equal to the constant plus the x1, because it's a no sign, meaning it's positive, and then minus this one because it is a negative sign, the x2. There you go. So B then says if x is 4 and x1 is 4, I'm sorry, and x2 is 11, what is the expected or predicted value of the dependent variable? Okay, so again, we've got our 84, and I put the variables in, so our 84.998, x1's 4, because that's given to us, and x2 is 11, again because that's given to us in the question. So then I just have to do the math, right? So this is equal to my 84.998 plus, and I'll need a parentheses, my 2.39, which I can get over here, okay, times, yep, my x1, and plus my, and I'll need that also, and I left that as a plus in this case because I have a negative value there, and so when I do the multiplication it's going to be plus a negative, so it will be a subtraction times my 11, and so there's my answer for B, which I probably should highlight. Ooh, bright yellow. I don't like that so much. So for C then it says how large is the sample? Okay, well, C then, how large is the sample? If you come over here and you look at this, our DF is for degrees of freedom, and we have a 64 degrees of freedom. Well, if you remember when we do degrees of freedom, it's generally -1, okay, and so our sample in this case is 65, our N is 65, okay, and I also put in there that our K is 2 if you went back, and we're going to need it for this equation anyhow, so our K is 2, which we get up here, okay. So, the 2 should stand for the number of independent variables that we have up here, x1, x2, okay. So pretty relatively simple answer there. Let's make that a little lighter color, not so obnoxious. So then D asks for conduct a global test of hypothesis to see if the set of regression coefficients could be different from 0. Use the 0.05 significance level. What is your conclusion? So we're going to see if this could be different from 0, and to do this we can calculate the F, and I'll do it the hard way here to begin with, and then of course I'll show you the easy way. But first we have to say we have to state our hypothesis. We're gonna, or our decision rule is reject the null if F is greater than 3.15, and that should be on page 736. I'll look for that myself. I didn't look for that earlier. When we look at the F values with degrees of freedom, I'm sorry, and we would look with a numerator of 2 and a denominator then of 65, which we don't have, okay, and we're at the 0.05 significance level. I believe that's correct. So if you go to 60, which is the closest, is where we get the 3.15. So that's all you can do sometimes is go to the closest one, okay. Then it gives us some of this information. Here's the equation to calculate F. So it gives us the SSR, right? SSR is the regression. SSE is the error, the residual error, okay. So I got SSR divided by K, which I know is up here, okay, and that whole thing is divided by SSE divided by N minus K plus 1, okay. And I put all that into a long equation. I think if you were to do it, it'd probably be smarter to do it something like this. This is equal to SSR, which I have here too. I guess I can do that, divided by K. And this is equal to SSE, or here, I'm sorry, divided by N minus, I'm going to need N minus parentheses K plus 1 parentheses. And then you could simply get that right. Yeah. Then divide the two of them, so equal to this one divided by this one. I should have the same answer that I have over there, 4.13765. And if we look over here, look at that. It gives us the F value actually. Okay. Well, that exceeds that, and so we would reject the null, right? Okay. So we would reject the null, and the null would be that they were equal to 0. Okay, and so we would say here that they are different than 0. Okay, then E says, conduct a test of hypothesis for each independent variable. Okay, here's our independent variables, and here's the information that we have for those. Okay, and use the 0.05 significance level, and which variable would you consider eliminating? So, again, they give us a lot of the information. We have to look up the t value. And if you look in the back of the book, they use 2, and I don't know if they rounded. Okay, I looked in the back of the book, and using a 64 for my degrees of freedom and a t value at the 0.05 significance level, I came up with 1.998. When you get up there, there's very little difference, right? I mean, we're talking 0.02 of a difference. Probably not going to matter too much. So then I'm going to reject the null if t, the calculated t, is greater than 1.998 or less than minus 1.998. So for x1, okay, I've put here I cannot reject the null. And why is that? Well, if I go to the ANOVA table actually up here, I've got 2.391 is my coefficient, my SE coefficient, but it actually gives me my t. Okay, and my t turns out to be 1.99. Ooh, so that, but it's still not greater than, right? We have to presume that that's 1.990. Okay, so it's not greater than, so I cannot reject the null. Okay, really close. So sometimes the rounding, I guess, could make a difference, but I cannot reject it on x2. However, 0.049 divided by 0.172, I get a minus 2.38, and that is less than that. So I can reject the null for x2. And so if I'm going to redo this, what I would do is I'd eliminate, okay, if I cannot reject the null for that, I'd eliminate that variable, and I'd repeat a regression analysis with just x2 as the independent variable. What that does is it takes x1 out in terms of trying to calculate those things. Okay, and we could have also calculated our t's here, which is b minus 0 over the, but it's right there in the table. Do it the easier way since they're giving you that information.